Hello everyone, we're going to continue on with the alternating series test. On this video I'm going to show you guys just a couple more examples. In the first video we talked about how to apply the alternating series test, when to determine when to use the alternating series test, and briefly we talked about the difference between the absolute and conditional convergence. I want to spend a little bit more time on that in this video, and there's a couple of examples that I want to do for you guys in this video. So we're going to go ahead and skip down here to these two examples that we've done right here, and we can look at, and for the purposes of this video we're going to make the assumption that these are all going to be alternating series. There is going to be an example I'm going to do in the third video that's going to show you guys one where it's not an alternating series. So the first thing we're going to do is we're going to look at this function right here and make sure that it follows the two conditions of the alternating series test. So what we're going to do first is make sure that the term 1 over the natural log of n plus 1, if this is greater than 1 over the natural log of n plus 2. Right? So is our first term always going to be greater than our second term. And so just like we did in the previous example, if we were to cross multiply this, then we're going to get that, will the natural log of n plus 2 be greater than the natural log of n plus 1? And that is always going to be the case, because again, we're making the assumption that n is going to be positive. Okay, so that first little part is actually good. And then the second part of this is going to say, all right, will the limit as n approaches infinity, remember we're just looking at our a sub n here, right, just so for a sub n, of the natural log of n plus 1. And so remember the n plus 1 really doesn't matter, so we're really just looking at the limit as 1 over the natural log of n. You know that this is approaching infinity, right? So it's 1 over infinity, so we know that this limit is going to be equal to 0. Therefore, we know this limit is also going to be 0. So I now know that this series is going to converge, right? So we know it's going to converge. Now, we need to talk about whether it's going to be an absolute or a conditional. And so, just like before, we're just going to look at this series. So I'm going to look at the series to infinity of n equals 1 of 1 over the natural log of n plus 1. And so what we're going to do with this is we're going to use a comparison test, the direct comparison test, to look at this function. And so over here, we're going to look at 1 over the natural log of n plus 1. Well, that's very similar to 1 over the natural log of n, right? That's pretty similar to that. And so we have also a way to figure out that this is also very similar to 1 over n, right? So because this right here is a little bit bigger than this, so we're very similar to it. So we know that this is going to directly compare to the series 1 over n, which we now know is a harmonic series. And since we know this is a harmonic series, we know that this can be a conditional convergence problem. For our next example, we can look at the fact that, again, we're assuming that this is going to alternate back and forth with our stuff. What's going to actually draw my attention really quickly is the limit as n approaches infinity of n over 10n plus 1, right? So again, we're just taking the limit of a to the n. If we're going to try to take the limit of n over 10n plus 1, I can see this limit actually equals 1 over 10, right? Because the highest degree of the numerator is equal to the highest degree of the denominator is equal to 1/10. So we automatically know that this series will diverge immediately. And we also know that we could look at the nth term or the divergence test to also know that this series is not going to converge. And one of the things I should have mentioned in the previous video is exactly what this is saying, that if the second condition is not met, and we're referring to our two conditions right here, if the second condition is not met, then you may be able to use the nth series test for convergence. And that's exactly what we showed right here in example number 3. Okay, so let's move on to another example. So now we're going to look at this example right here. And we're going to also make the assumption that it does alternate between positive and negative values. The alternating series test, the first thing that we must choose is we're just looking at this. So one thing I would just say really fast is that a sub n is going to be equal to 1 over n cubed. So that's what we really care about for the alternating series test, because again, we're going to make the assumption this is going back and forth between the two. So we just want to make sure that 1 over n cubed is greater than 1 over n plus 1 cubed, right? And that's a pretty obvious thing to think about here, because this number is much bigger than this number right here. What I've been tending to do to show this is cross multiply this right here, and since n is positive, a bigger number cubed is going to be much greater than a smaller number cubed, so I know that this condition is definitely met. The other thing that we want to do here is we're going to look at the limit as n approaches infinity, again, of just our a sub n, and just like before, it's a bottom-heavy function equals 0, so we know that this also is true. So I now know that this series is going to converge. Now, the problem's actually told us to show that it's an absolute convergent problem. Well, that's actually pretty easy to show as well, because what we're going to do now that we know that it converges using the alternating series test, we want to look at just the a sub n term, which is 1 over n cubed, and this should be familiar to us that this is actually a p-series problem, because remember, this is where we have a variable to a power. Remember that 1 harmonic less than 1 p-series diverges, greater than 1 p-series will converge. So I now know that this actually also will converge here, right, about the p-series test. So I can now say with full confidence that this series here, this series right here, is going to absolutely converge. Okay, so that is 3 pretty straightforward examples. I'm going to do another video with more of these. So I'll see you guys next time.